Alright, so today we are going to be working on subtracting polynomials, which makes sense because yesterday we were working on adding polynomials. So today we're actually going to learn 4 different ways on how to subtract polynomials. They're all pretty similar to the strategies that we learned yesterday, so I'm sure you'll pick them all up pretty quickly. So I've already gone and written and rewritten and highlighted this first problem because I have so many math videos on my phone that I actually ran out of storage part of the way through the video. So I'm going to explain what I did, and I'm sure you'll catch on. So when I wrote this problem, 7y cubed minus 6y plus 15 minus negative 5y cubed plus y squared minus 2y minus 8, I realized that there was more terms in this second polynomial than in the first one. So I figured out which term was present, which like term was present in this second polynomial and not in this first one, which ended up being the y squared. So I rewrote this polynomial to include the y squared term. I just represented it with a 0 as a placeholder. So it didn't change the value of this first polynomial, but it made it so that way each of these polynomials have the same amount of terms. So then I went and highlighted all of the like terms. So we have 7y cubed minus negative 5y cubed. Now it's very important to remember your subtraction rules with integers. So 7y cubed minus negative 5y cubed, you get 12y cubed. Now we have 0y squared minus y squared. Now the whole reason that I wanted to add this placeholder is so that I wouldn't forget that we're subtracting it, because it's a lot of people's first instinct when they just see a term by itself to just bring it down. But 0 minus y squared isn't y squared, it's minus y squared. So that's why I added that placeholder. If you see that right away, that it would be negative y squared, not plus y squared, don't worry about the placeholder, but I still use the placeholder, and I've been doing math for a very long time, so I do suggest using it, but it's up to personal preference. So then we have our purple terms, which is negative 6y minus negative 2y, and you end up with minus 4y. And then we have our blue terms, 15 minus negative 8, so you get plus 23. Check that you don't have any extra like terms, and we don't, so this is our final answer. Now, I'm going to add, for this second problem, we're going to add a little twist onto the horizontal subtraction. So we have 5x squared plus 3x minus 6 minus 3x squared minus x plus 5. Now, what I mean by little twist is that I'm going to change this into an addition problem by using the distributive property. So this here, you could really say, is like saying minus 1 times 3x squared minus x plus 5. So I'm going to distribute this negative 1. So that way we're left with 5x squared plus 3x minus 6 plus negative 1 times 3x squared, negative 3x squared plus x minus 5. So now this looks like what we worked on yesterday. So I'm going to highlight my like terms. So we have our 5x squared, and its like term is negative 3x squared. And then we have a 3x. And its like term is this positive x here. And then we have our -6 and our -5. So we're going to go through and combine. So we have 5x squared plus -3x squared, which leaves us with 2x squared. Then we'll look at our yellow term. So we have a positive 3x plus an x, which leaves us with 4x. And then we have a -6 plus a -5, which leaves us with 11, -11. So then double check that we don't have any remaining like terms. We don't. So this is our final answer. So now we're going to move on to vertical subtraction. So our first problem, we have a cubed minus 2a squared minus 3a squared minus 4a cubed. So we're going to rewrite it vertically, similar to how we did it yesterday. So we have our a cubed minus 2a squared minus, and we have our -4a. Remember to keep that sign with it. And we have our positive 3a. So we have, oops, I forgot my exponents here. That would have been unfortunate. All right, so we have a positive a cubed minus a -4a cubed, which leaves us with a 5a cubed. And then we have a -2a squared minus a positive 3a squared, which leaves us with a -5a squared. We check that we don't have any leftover like terms. We don't. So this is our final answer. For our second vertical subtraction problem, we have 3x cubed plus 4x squared minus 2x cubed plus 3x squared minus x. I'm going to distribute this -1 again, this invisible 1 that sits here. So that it changes the problem. Doesn't change the value, it just changes the problem a little bit, the way it's written, to 3x cubed plus 4x squared plus -2x cubed, or yeah, it's cubed, sorry, minus 3x squared plus x. So now, similar to what we saw earlier, we have more terms in this second one than we do in this first one. We have this extra x term that's not over here. So when I rewrite it vertically, I'm going to add the placeholder to this first polynomial. So we have 3x cubed plus 4x squared, and then I'm going to put plus 0x. So then we're going to bring these down, so we have negative 2x cubed minus 3x squared plus x. And since we changed this to addition, we're adding. It's just like what we did yesterday. So 3x cubed plus a negative 2x cubed is x cubed. And then a positive 4x squared plus a negative 3x squared leaves us with an x squared. And then a 0x plus a 1x gives us an x. Check that we don't have any like terms. We don't, so this is our final answer. And that's it for today.